Hi everyone, today we're going to have a look at indices and investigate index notation. So by the end of this I'm hoping that everyone can represent a number in index form and expanded form and evaluate a number that's already in index form or in expanded form. So let's look at what all that means. A number in index form has a base and a power. So here we have a number in index form. The 2 is the base, the 3 is the power. The 3 might also be known as an index, or indices. So we'd say this number here as 2 to the power of 3. 2 to the power of 3. Now, other examples could be 2 to the power of 7, 10 to the power of 4, 8 to the power of 6. So as I said earlier, indices is the plural of index and is the general name for the topic that focuses on numbers with an index. So the index itself represents how many times to multiply the base. So 2 to the power of 3, given that 2 is the base, we're going to multiply it by itself 3 times. 1, 2, 3 times. 2 times 2 is 4. 4 times 2 is 8. We call this the index form. When we expand it, it becomes 2 times 2 times 2. That's called expanded form. When we evaluate it, it's as a numeral, and it would just be the number 8. Now we could do 3 squared in expanded form. That would be 3 times 3. Now we've written it from index form to expanded form. 4 to the power of 3 is 4 times 4 times 4. 10 to the power of 4 is 10 times 10 times 10 times 10. 10 4 times, multiplied by itself. Whereas if we were trying to evaluate it, we know that 3 squared is 3 times 3. 3 times 3 is 9. 4 to the power of 3 is 4 times 4 times 4. 4 times 4 is 16 times 4 again is 64. And 10 to the power of 4 is 10 times 10 times 10 times 10, which would be 10,000. If we had it in expanded form and we were trying to put it in index form, we would look at it and say how many times is the same number multiplied by itself? 1, 2, 3, 3 times. That would be 3 to the power of 3. How many times is 4 multiplied by itself? Well, 4 is multiplied by itself twice, so it would be 4 to the power of 2. In this case, 5 is multiplied by itself lots of times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be 5 to the power of 10. We can evaluate sums that have different bases. We just have to be careful to evaluate them correctly. So 5 to the power of 2 times 2 to the power of 2. 5 to the power of 2 is 5 times 5, which is 25. 2 to the power of 2 is 2 times 2, which is 4. 25 times 4 is 100. 2 to the power of 3 times 4 to the power of 2. This is getting too complicated to do in my head, so I'm going to write it out. 2 to the power of 3 is 2 times 2 times 2. 4 to the power of 2 is 4 times 4. Now, because I'm multiplying everything, the order is not important that I do it in. Multiplication is commutative and associative. So let's do this bit. We're going to have 2 times 2 is 4, and 4 times 4 is 16. And not multiply everything by 2 yet. And then I might do 4 times 16, because I know 4 times 16 is 64. And then I get 2 times 64, and if I double 64, which is why I've held this 2 to the end, because doubling is easy, 2 times 64 gives me 128. Now, you could have done 2 times 2 times 2 is 8, and 4 times 4 is 16, and 8 times 16, and hopefully known that that's 128. It's up to you. I did it in little steps to make it easy for myself. Your calculator can do sums with indices. It has different calculators have different buttons. You need to look for X with a little square up the top, a caret symbol, which is like an upside down V, or X to the power of Y, depending on which calculator you're using. The one suggested by the school has this X with a little box above it. So 2 to the power of 3 would be 2, X box. That's funny. You can play Xbox on your calculator. Look for the X with a little tiny box above it. Press that, then press 3, then press equals, and it would give you an answer of 8. If we're doing 2 to the power of 3 plus 3 to the power of 2, 2, x with the box button, 3 plus 3, x with the box button 2, 3 with the box button 2 is that button, then equals, and it would give you an answer of 17. The very last thing I want to go through is that there's two special cases with index laws, or indices itself. We talk about squared numbers, and a squared number is just a number that's to the power of 2. We say it in a different way, but we mean the same thing. So 2 squared is the same as saying 2 to the power of 2. 5 squared is the same as saying 5 to the power of 2. Numbers raised to the power of 3 are cubed numbers, and they can be said a different way. 2 cubed is said as 2 cubed. 5 to the power of 3 is said as 5 cubed. We could just as easily say this as 2 to the power of 3 or 5 to the power of 3, but the more common way of saying it is 5 cubed and 2 cubed. It's a bit like saying a buck for a dollar. It's a different way of saying the same thing. It's good to know your squared numbers up to 10 from your times tables. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, so on and so forth, down to 10 times 10 is 100, and at least up to 5 for your cubics. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. There was a lot there, so you might want to watch this again, and make sure that you know this for your upcoming test. Thanks everyone.